I'm Val, and I'm excited to welcome you to Northcoders' remote graduation stream. Our students have been busy learning and experimenting, and today we have 3 teams ready to present their final projects for you. If you have any questions on the presentations, please pop those in the chat. The teams are all available to answer those. Our first team is Travel Buddies. Over this year, I've come to realise how much I enjoy exploring more local places, and this team have created a platform to discover, review and share hidden gems from our explorations. This is Travel Buddy.
Hi, I'm Austin.
My name's Roz.
Hi, I'm Steve.
And I'm Helen. Together, we've created Travel Buddy, a web application where adventures come to life. Users can explore hidden gems of travel internationally or on their own doorstep, brought to them by their fellow travellers. We wanted to create a site which met the needs of independent travellers, a way to plan new trips or discover secret spots, and view locals' top tips to create a truly authentic travel experience. As a user content-driven platform, users would be encouraged to post their own experiences to create a database of exciting ideas of things to see and do off the beaten track. With a front end using React, styled components, Axios, Firebase and React Leaflet, we built a back end using Express, GraphQL and completed TDD with Jest. And now, over to Steve.
Here we are, on the site, logged in as user Rumbling C#, real name Ikra Jensen. Ikra is visiting York and using the platform to find things to do. With geolocation enabled, the home screen loads with the React Leaflet map component centred on her current location. Above the map, we have a range of controls which allow Ikra to gather more information about the site or go to an area of the site she would like to visit. The GraphQL backend serves up the pins requested by Axios, which are displayed on the map to show Ikra the experiences already added to the site. Ikra can click on a pin, which will display a pop-up showing the experience, title, date and username. She can then choose to close the pop-up or follow the link to view the full experience screen. The full experience is fetched from the backend and rendered along with any related comments. Ikra can like and comment upon an experience and like other users' comments. This performs a GraphQL mutation on the backend, which in turn updates the Postgres database with the new data.
Whilst visiting York, Ikra also uses the site to tell others about a great experience she had there. Clicking on the screen at the relevant location drops a pin on the map and simultaneously makes a pop-up appear, asking Ikra if she would like to add her experience at that location. She can then follow the link to upload her own experience for others to see, like and comment upon. If she wants to add any hashtags, she can include these in the description field. She also has the option to upload an image to accompany her experience, which is then stored by Firebase storage. The form can't be submitted unless all fields have been filled out. If Ikra changes her mind, she can easily delete her experience.
Hi, my name's Steve, and I'm going to talk about our tech stack. When considering our tech stack, we wanted the finished site to be fast and responsive for users on the move. We used React to create our project, taking advantage of the components element, which meant that we could share development across the team. As we all had experience in React, it allowed us to make better choices about planning the wireframes and be confident that it would work without other tech choices, one of which was Leaflet Map and React Leaflet. We wanted a map the user could easily navigate to find and post experiences. We chose Leaflet because it's a lightweight and flexible API with simplified integration on the front end and its own pre-built React component. We also felt it was the most open source option. We also used Axios as it's familiar tech to us. Further, being a promise-based library, we knew it would be easy to query the backend API. During development, we realised that we would need to use cloud-based storage in order to host the images, which are integral to the site. So we chose Firebase, as it provided a clear and easy route to cloud storage. Being a Google product, we also knew it could cope with the expanding needs of the site as it grew and could provide a long-term storage option. Finally, on the front end, we chose styled components to create our CSS, as its modular nature allowed us to keep our CSS and styling separate to the main components. When it came to building the back end, we used the Express framework due to its lightweight nature and wide ecosystem of plugins. For our database, we used Postgres due to the relational nature of our data. And after spiking, we decided to use GraphQL API in order to take advantage of its single endpoint. It also allowed the front end to send a request for exactly the information it required. Finally, we used Jest for our TDD. I'm going to hand you over to Austin. Thank you.
As the project developed, we encountered several problems with the tech stack that we'd chosen. An early blocker was the more complicated nature of GraphQL. We found that supporting documentation was lacking in detail in certain areas and was difficult to implement. It was a steep learning curve, but we found that with a lot of research and some trial and error, we were able to solve any problems that we had. And as GraphQL is used throughout the entire project, we were able to apply lessons learnt on the back end, such as how to structure queries for automated testing, to the front end where we had to request information from the API. We also had difficulties with React Leaflet. During our spiking, we were impressed with the React compatible nature of the API and that it was truly open source. However, when we began working with it, we realised it had certain limitations. For instance, React Leaflet was not compatible with star components, and so our styling options were limited. It was also very difficult to get an information pop-up to appear in front of the leaflet map layer. In fact, the only way that we could do this was to have a very high z-index value in the CSS. Now, Ros will take you through some of the soft skills that we've developed whilst doing this project.
Thanks, Austin. Organisation was key to the success of our project. Throughout the process, we used Agile-inspired practices to achieve this. Regular contact with the team was integral to staying organised. Most days would start and end with a stand-up to ensure everyone stayed up to date. Our Trello board was the heart of our project, as we used it daily with stand-ups so we could easily see our progress. Nothing feels better than moving a task onto the done list. Opting for the mobile-first approach, we used Figma to rough out the basic functionality we wanted. Figma's preview feature meant we could easily create specific user stories whilst working remotely. We then made more precise wireframes of each screen, considering fonts, colours, layouts, and smaller details such as like buttons and input fields, in an effort to make the app distinct from other map-based applications. Pair programming simplified some of the bigger tech stack issues, and we appreciated the peer support aspect of cracking a difficult piece of code. Getting to grips with shared Git repos was an exciting experience, and at first we all found merging branches a bit scary. But our Git skills have improved immensely. We've learnt it's not as scary as we first thought, and careful deliberation will solve most problems. Now back to Helen.
Overall, we're pleased with our project. We feel it is a modern, welcoming site which meets our audience's needs. Upon reflection, initially we were over-ambitious about the number of features our project would contain, not yet realising what was realistic for a 2-week, 4-person project. Further developments we would like to implement include the ability for a user to search the map using both geographical locations and also user input hashtags. Further, we would develop the site to be able to offer suggested personalised trip itineraries based upon a user's interests, and this would be compiled of the experiences that other users have left. Thank you very much for listening to our presentation. We're available to answer questions in the chat below, should you wish.
Thank you, travel buddies. Let's give them a warm round of virtual applause. And don't forget, if you have any questions, to pop them in the chat. If you're finding yourselves and your children more often at home than out and about, this next app is for you. Team Alpha have created a platform to track and incentivize our little ones to complete their chores. Please welcome Team Alpha and their app, uStars.
Hi, my name's James and we're Team Alpha, and we'd like to introduce you to uStar. uStar is a child monitoring app that was produced as an incentive for promoting good behaviour in children. It was inspired by a friend who wanted a way of rewarding their child for good behaviour. Myself and Shalom will now give you a brief demonstration of the app and give you a feel for how it works. So please sit back and enjoy. When a parent opens the mobile app, they will see the main home screen. From here, they can click on a number of options. First, we will click on the How to Use button. On the How to Use screen, it shows how to set tasks and rewards. The parent will now sign up so that they are able to use the app. I will now sign up using Firebase authentication. Now that Tom has signed up, he's taken to the main profile page. Here he can see his name and his email address, and he can add a child so that they are able to use the app. Now that Tom has added his child Jim, he can see Jim's name, his star count, and he can set him tasks and rewards on the next page. On the task page, Tom can now set Jim a task. And now Tom can set a reward for Jim too. This gives Jim something to aim for, even if I do say it's a steep price. Once Tom is finished with the tasks and rewards, he can go back to the profile page where he can see the login code for Jim so that Jim is able to sign up. I will now pass it over to Shalom, who will run through how Jim will sign up.
We designed the child login process to make it as simple as we can for the child. They don't need to put in any of their own data. All they need to do is get the login code from their parent and put it into their phone. Once the child is logged in, he can now see his rewards, his tasks page, and his rewards page. He's able to buy rewards, remove rewards, and if he would like to, he can add his own rewards. Once Jim feels like he's cleaned his room well enough, he can click Request Review, which will change the task status to pending. When Tom logs back in and views Jim, he can see that he has changed the task status of clean room to pending. Now he can go and check Jim's room to see it's clean. Now that it's clean, he can confirm requests. Now the task status is automatically changed to completed, and Jim has increased his star balance by 5 stars. Now Jim can see that his parent has marked his task as completed and that he's gained 5 stars. So now he can go onto his rewards page and spend the stars whichever way he likes. Jim chooses wisely. Now that he's bought the ice cream, we can see that his star count has gone back to 0. I will now hand it over to my colleague Adil, who will describe the tech stack we used in the back end of our project.
The tech stack for our backend was based on Node.js with the Express framework. We went with Postgres as our database management system, which we were already familiar with and needed a relational structure in order to have the parents and children easily connect together. We used Connects as a query builder as it's easy to use and kept our code clean by allowing us to use promises. Miscellaneous utility functions we created to manipulate our data we unit tested using Jest, which includes both a test suite and an assertion library. We then tested our endpoints using Supertest. Finally, we hosted the backend to our app on Heroku, which allowed us to quickly deploy it so our front end could begin to make its requests.
For the front end, we wanted to use new technologies we didn't learn on the course, such as Expo and Firebase. We wanted our project to be on iOS and Android platforms, which gave us a choice between Expo or React Native. We chose Expo over React Native because React Native had different modules for Android and iOS, which meant you had to code separately on the front end for Android or iOS platforms, and this was not feasible in the time given. Expo, however, builds on both platforms with the same line of code. Expo also has over-the-air deployment, meaning we don't need to deploy on Google Play or App Store, and it automatically updates on the deployment. Axios was also used as we were most comfortable with it on the course, and it also had the added benefit of automatic JSON serialization, unlike Fetch. Firebase was also used for authentication while logging in as the user. Firebase was also used for authentication while logging in, as we wanted to secure user information that was sensitive. Next, we'll go over to the challenges. One of the challenges we faced on the project was remote collaboration due to lockdown, which was solved by using Slack, Zoom, Discord, and LiveShare, as well as using agile-inspired practices of stand-ups, pair programming, and regular check-ins. Another problem that we faced was spiking and adjusting to Expo and Firebase. We recognised how big these technologies were, and by splitting into pairs to learn Firebase and Expo separately, we knew we could learn as much as possible. A third problem that we faced was Firebase in React versus React Native. Now, during our time together, I realised that James learnt Firebase in React instead of React Native, and in order to address this, we created our own login sprint to get the functionality that we wanted.
Throughout the project, we made use of many agile practices. Each morning, we had our daily stand-up and regularly checked in with the team throughout the day. Our tasks were displayed clearly on Kanban boards on Trello, which allowed us to visualize progress and adjust the course of the project if necessary. We made use of pair programming and even mob programming when we needed all hands on deck. Our independent researching skills were honed when spiking our tech stack and reading new documentation. Due to the nature of working remotely, naturally, we improved on how to communicate and work with each other effectively over long distances.
In the short time we were given, we were able to achieve the core functionality that we set out to do. However, there were some extra features that we would have liked to have added to improve the user experience. As we are dealing with potentially sensitive data, we plan to add an encryption key onto our API so that only app users would be able to access their data and only their own data. We also looked into creating push notifications so that when a parent would set a new task or a new reward, or reward some stars, the child would be immediately notified. Additionally, when a child would request a task review or spend stars, the app would notify the parent. We also thought it would be useful for the parent to be able to change their password and to be able to generate a new login code for their child.
Stylistically, we could easily add in a day-night theme feature. and an image picker for children to select their own avatar. We even thought about social media integration, but decided it might not be suitable for younger children. However, an internal leaderboard with parent-approved friends or siblings is something we could choose to implement in the future. Overall, we are proud of what we managed to achieve in 2 weeks, as we completed all of our core functionality and created an app which we are happy to share with you today. Thank you for listening, and we are happy to answer any questions that you may have.
Thank you, Team Alpha, even if your price for ice cream is steep indeed. A round of applause, please, and if you have any questions, please pop them in the chat. Our next team, Team Hive, have found lots of pros to remote learning, as well as some downsides, and they have created a platform to help coding newbies to find help with debugging their code by asking more experienced mentors. Please welcome Team Hive and their app, Hive Got Bugs.
Hi, I'm Stephen Bradshaw, and I'm here with Kojo Kawachi, Jasmine Lloyd, and David John to tell you about our web app, Hive Got Bugs. Hive Got Bugs is a site where junior developers can share solutions to common coding problems, while also having access to expert, personalised help from an experienced mentor. With remote working fast becoming the norm, as a team, we felt that we would all benefit from having access to an online community of junior developers after graduation. While there are many sites that allow users to answer each other's tech questions, there are comparatively few that are aimed specifically at junior developers and that also offer the opportunity for a more personalised mentor-mentee relationship. So, let's find some bugs. Here we are at the homepage of the Hive Got Bugs site, and I'm going to log in using my GitHub account via Firebase authentication. So, I'm now logged in, and I can view a list of unsolved coding problems posted by other users. I can sort these by the date they were added. I can also filter them by the kind of tech they use. Here I'm going to look only for HTML problems. Alternatively, I can filter the problems by difficulty, in this case just showing the easy problems. Here I'm going to have a look at a problem called drop-down menu, which is to do with HTML. Here's the page for that problem. I can view suggestions that have already been added, as well as adding my own. Here, I'll add a suggestion recommending some online documentation. Once the suggestion has been added, I can edit it, or I can delete it. If I have a problem of my own that I'd like to get help with, I can add this by visiting my dashboard. The dashboard page shows my profile picture, which the site has access to through the GitHub integration, and also shows the number of bug points that I have. Bug points are earned by solving problems that other users have posted. The dashboard also shows charts, which provide a summary of the tech used in the problems I've posted, and also the ratio of solved to unsolved problems. So, now we're ready to add a problem. I've filled in fields for the tech I've used, the problem's difficulty, and a description of the problem itself. And now I'm going to submit it. Great, so that's been added to the site. Now that I've added a problem, I feel that I could really do with setting up a relationship with a mentor. To do this, I'm going to access the mentors page and have a look through the list of available mentors. I can see information like the skills a particular developer has, their bio, and the number of bug points they've collected. In this case, I'm going to contact Sarah Smith by visiting their GitHub account. I could then follow them and send them a message on GitHub to get help with the problems I've posted. Kojo is now going to demonstrate the process of how you become a mentor.
Hi, I'm Kojo. I would really like to become a mentor, so I'm going to click on the Become a mentor button. Oh, I don't have enough bug points. Let me go to the home page and see if there's any problem I can solve. Here is a problem by Stephen. I'm going to add a suggestion to this.
So I've come back to the app a little bit later, and I'm going to pull up the problem that I added. Okay, there's a new suggestion here by Kojo, and I think this has adequately solved my problem, so I'm going to mark this as having solved it. Great, this suggestion solved the problem, and my problem has been marked as solved. This should mean that Kojo has received a bug point.
Okay, so I'll go back to my dashboard to see how many points I've got. Oh yes, I've got 10 points. And now that I've got points to become a mentor, I'll do that right away. I will then fill out this form to become a mentor. I'll provide my name and my area of expertise: JavaScript, React, and Rails. I will also provide my GitHub name and then a summary of my details. I will go to the mentors page. You see I will be added as a mentor. Now I'm going to tell you about the tech stack we use for the front end. We use React for the front end. Even though we were familiar with React, we wanted to reinforce our understanding of the framework. We also use star components, as it's more compartmentalized and less chance of CSS interference. It keeps track of what components are rendered, so only renders the least amount of code, which is good for efficiency. Another advantage of star component is it provides dynamic styling using props. We also use Firebase for authentication on the front end and get users' detail like profile images, so no need to store images. Then we use Axios to access the endpoint through API calls. We also use Chart.js to visualize data and to render stars on our dashboard. And then finally, we use Netlify to deploy our front-end application. I'll now hand you over to David to tell you about the backend.
For our tech choices for the backend, we used Heroku to host the backend due to its ease of use and implementation. This meant we could quickly host our backend and use our endpoints as they were tested and created, which meant in turn the front-end functionality could start much earlier, cutting down on wasted time. In terms of our database, we toyed with the idea of changing what database we used, so we could sort of expand and learn new skills. For example, the popular one is MongoDB. However, for our application, PostgreSQL served our purposes perfectly, as our data was relational due to having users having things like problems, suggestions, and bug points associated with them. Another perk of using a relational database meant that when we had to delete a user, or more commonly a user's problem, it deleted all the associated suggestions to that problem, meaning it could be done efficiently and quickly. In regards to the data to seed our database, we use an npm package called Faker. We use this because it gave us access to a large library of data, which we could tailor to our database schemas. For our server, we use Express to create our server and Connect as our query builder for our endpoints, as our app was fairly front-end heavy, so it made sense to use something that we all had experience on. This meant we could focus on the front end and get the back end up and running as quickly as possible. Our testing was carried out using Jest, in which we thoroughly tested each endpoint before it was hosted. Over the course of our project, we faced several challenges that we had to overcome. One of the biggest was the fact that it was done completely remote, which meant we had to rely on communication and organisation skills to make sure our tasks were done in time and people didn't overlap on tasks they were doing. We used agile practices like regular stand-ups to keep everyone up to date with what was going on with the app. This meant everyone had a clear idea on what was happening with the look and functionality of the app. Another challenge we faced was creating data in which we could use to test our database, as this is something we have had not any experience in doing before, so we had to start from scratch and go out and research what would be the best way to go about solving this problem. We needed to find a way to get the data that could be tailored to fit our specific schemas, as well as in the correct data type. We finally decided on Faker due to its straightforward implementation and the wide range of available data that we could use to fit our schemas.
We were able to create a fully functioning application in just 2 weeks, which was a great accomplishment. By using regular stand-ups and updating the Kanban board on Trello, we were able to stay constantly updated. We also had a prototype using Figma that allowed everyone to see the design at any point during the project. We also used pair programming and mob programming to make sure everything worked and appeared as we agreed. It was very important to have regular stand-ups throughout the day to make sure that if there was any issues we could tackle them as a team. Something else we did as a team was create a wireframe of the website. This helped replicate how we would work on a project in a professional environment. Due to the time constraints, we decided to only implement authentication on the front end. If we were given more time to work on our project, the first thing we would do would be to implement authentication on the back end as well. We would also implement instant messaging using Socket.io, which allows messages to be sent between a user and a mentor so that there is more communication between the different users in the site, making it more unique compared to the other sites that we were inspired by, like Stack Overflow. To further improve the site, we would also add the functionality that allows users to be assigned a mentor when they first sign up. As the site scales, we would implement a system to split up groups of mentors and users into location-based cells. This is to help keep the sense of community and retain the original appeal of the website.
We hope you've enjoyed hearing about Hive Got Bugs. If you've got any questions that are bugging you, feel free to fire away in the comments. Thanks for watching.
Thank you, Team Hive, and very well done to all the teams. I hope you have enjoyed the projects we had for you today. The chat will remain open for another couple of minutes if you have any further questions. Congratulations to the 3 teams once again, and thank you everyone for joining us. I hope to see you at our next Northcoders graduation.